So the lesson on 1.3 is about functions and the graphs and the properties of those graphs. So there's going to be a lot of vocabulary coming at you here in this section. Let's start with some definitions. Domain, there's a formal definition, but we're just going to write down all the x values. It's the x values for which the function exists. The range would be all the y values. The X-Intercepts, if you take a visual definition of X-Intercepts, it is where the function crosses or intersects the x-axis. And X-Intercepts, because they're crossing the x-axis, will be some x value, but the y value will always be the number 0. So then a Y-Intercept is where the function crosses the y-axis, and then kind of like the X-Intercepts, since you know it's going to cross the y-axis, the x value has to be a 0 and the y value will be whatever number results from that. The increasing interval, it's a little hard to write a definition of an increasing interval. We're going to show it in the next few examples. It is where the function increases, not a great definition, when viewed left to right. Now, you might want to make a note, increasing intervals, even though it's asking about the function, which is the y values, the way it looks is that it's a domain interval. We'll talk about this in a second. And then decreasing intervals would be where the function is decreasing or going down from left to right. And again, seeing an example of it, it's a little easier to understand. So again, decreasing interval is another domain interval. A constant interval is where the function maintains the same y value when viewed from left to right, of course. So if you kind of want to picture an increasing interval would be, if you think about like reading it left to right like a roller coaster almost, anything that kind of goes up like this in a curve. Could be steep, could be shallow, it doesn't matter. Decreasing interval would be going down. And it doesn't matter where the arrow is on the end point, it's just the path of the roller coaster. And then a constant, of course, would be horizontal and flat. A discontinuity, we're going to call it an interruption. Oops. In the domain. And there's a few different types of discontinuities that we're going to talk about. We're going to talk about holes, jumps, and I don't think we're going to see them too much, but there is another discontinuity called an oscillation, which occurs more in calculus and then subsequently in real-life applications. So, in number 1, they gave you a graphed function, and they want you to answer a whole bunch of things. So those things that we just defined, domain, range, x-intercepts, y-intercepts, that's what the A, B, C, D, E, F, G, H stands for. So A was the domain, and I notice if I look at where my function stretches from left to right, the domain starts at -4, and I'm going to put a bracket on that because it does have a point at -4, and we're talking about the x value here. And then it goes all the way to the right, but what's kind of weird about the right is it does go towards 4, it has an open circle on 4, so I need to put a soft parenthesis because it doesn't actually have a landing point. Now for range, that would be the y values, or low point to high point for the y values. So again, filled in circle down here at -3, bracket. And then up here at +3, it has a hole, so it doesn't actually hit that point. I need to put a soft parenthesis. The next question asks for the x-intercept. The x-intercept would be where it crosses the x-axis. So you could either write the whole ordered pair of 0, 0, or if you just say x equals 0, that's fine. D is the y-intercept, which happens to be the same exact point. If you don't want to write the ordered pair, you could just say y equals 0. And for E, it says the increasing interval. So if this was a roller coaster, I have to look at any turning points. And if you notice, kind of a weird roller coaster, it is going uphill, a positive increasing behavior all the way through its domain. So the increasing interval is from negative, I'm going to call it negative 4 to 4, and notice I'm going to put parentheses on both of these. Now depending on what book you're in, they might use brackets. I don't like to call the endpoints here brackets for increasing and decreasing, because when you're standing still, there's no inflection. I can't really tell you if you're increasing or decreasing. So I'm going to always use parentheses on the intervals for increasing and decreasing. Letter F was decreasing, and notice this roller coaster was going up the whole way, so there is no interval where it is decreasing. G was constant, so it is never a horizontal section. And then H is the discontinuity, any place where the domain is interrupted, and that would be right here and you want to give the x value of the discontinuity. So at x equals 4, there is a hole, which is one of our discontinuities. Okay, same questions we're answering here for number 2, and I know you can't see it on this screen, but on your paper you'll notice there are arrows. So when they ask for domain, how far to the left and how far to the right, this guy goes forever to the left and forever to the right, so we say negative infinity to infinity. For your range, that would be how low to how high, and notice it starts at negative 4 with an actual point, so it's a bracket, then it goes up forever. And then part C says X-Intercepts. I notice it has 2 X-Intercepts, and again you can write the whole ordered pair if you'd like. So that would be 1, 0, and then also at negative 3, 0. Oops. And then Y-intercept, where it crosses the y-axis, is at the point 0, negative 3. And then they want to know about increasing and decreasing behavior. So if I read this like it was a roller coaster, and I started on the left, it's going downhill, so it's a decreasing function until I get to this turning point right here, and then it changes to an increasing function. So for part E, it says, what is the increasing interval? Well, that starts right here, which if I think about what domain point that is, that's a domain point of negative 1, because that is the x value. So from negative 1 to forever, it's an increasing roller coaster. And then for F, decreasing, from negative infinity, which would be all the way to the left because it goes forever that way, until it gets to the point negative 1. That's when it was a decreasing roller coaster. There are no constant intervals, and there are no discontinuities. There's no holes, jumps. Oh, there's another kind of discontinuity called an asymptote. We will see those later. Oh, 3 is a mess. Okay, number 3. The domain. It hits every single x value until it has a big issue right here. And notice on both parts of this function, there is a hole here and here, indicating that this point doesn't actually exist for this function. So my domain goes from negative infinity until it reaches the point of 2, and I'm going to put a soft parenthesis and then pick up again after 2 to infinity, because every single point in the whole world is fine except for 2 for the x value for domain. Now for range, it starts way at the bottom, so it starts at negative infinity, and then there's a hole right here at the point negative 1, so I need to put a soft parenthesis on there. Now this one's weird. It doesn't pick up again until it hits a 1, and then it goes up forever. And it's a weird function. Letter C asked for the X-intercepts. Notice it never crosses the x-axis, so there is none. The Y-intercept would be the point 1, or 0, 1 I should say. This function is going decreasing behavior here, and then it kind of has this weird pivot point where it starts being constant, and then it jumps, and then it goes to a decreasing behavior again. So there was never a point where this function was increasing. There were several points where it was decreasing. So from negative infinity until it gets to this point, which is for the domain negative 2, and then union, it picks up again with this decreasing behavior at 2, and then continues to decrease forever to the right. And this time we actually do have a function, a part of the function that is constant, and that was between negative 2 and 2. Notice I'm putting parentheses on all of those. And then the last thing is we do have a big discontinuity right here. So we're just going to say at x equals 2, And you can qualify it. There's holes, there's a jump, it's a big old mess. Alright, use your calculator to find the x and y intercepts and any local extrema, which means a maximum bump or a minimum bump. And we're going to round it to 3 decimal places. So, on my calculator. Oops. I want to make sure I'm still recording. You think I am? Okay. So, I'm going to go to y equals, and I'm going to program it with the new function, which is x squared minus 5x, x minus 9. And I'm going to zoom 6 to a standard window. And, apparently that's not a good window. I need to go lower. So I'm going to take my window and I'm going to extend my y minimum down to, like, I don't know, just let's be safe and say negative 30. So remember, my calculator can find all these things for me, and I can tell by the directions they're probably not pretty. So let's find my x-intercepts first. So x-intercepts are found by using the zero finder, and you got to follow the instructions, and you have to find them separately. So go a little bit to the left of one of the x-intercepts, a little bit to the right, and then enter one last time. And I need to write that down before I get it. It's negative 1.41. Oops. Alright. And then we're going to do the same thing and find the other x-intercept. I'm just going to cheat and say 5 is to the left and 9 is to the right. And notice it's doing the scientific notation thing again, kind of weird. But the x-intercept is at 6.41. Alright, and then back to my calculator, I need to find the y-intercept, which should be really easy. I'm just going to hit trace to pull up the cursor, and then a 0 is what the x value is on the y-axis, and if I hit enter, it tells me the y-intercept is at negative 9. And then the last thing I need to find is that little minimum bump. So second trace, choose minimum finder. Okay, I'm already left, that's good. Go to the right of your minimum. And then enter one last time, and you need to write down the entire ordered pair of 2.5 comma negative 15.25. You have all those things. So the y-intercept I think was at 0, negative 9 if I remember. And the minimum, oh geez, I already forgot. I think it was 2.5, negative 15.25. And you would plot all these and sketch it and life would be good. Alright, that's enough of that. Oh wait, did we have to do anything else? Nope. Alright, number 5 is interesting. I actually don't know what this looks like, so I'm going to need to grab my calculator and get this typed in. So it's the square root, and then to pull up the absolute value, you go to the math menu, over to number, and then the very first choice, ABS, means absolute value, of x squared, and then subtract 12. And this one is going to look a little strange. Graph. Now I should go back to a standard window, but this is fine. Well, I'll go back. Zoom 6. So, notice, it's kind of interesting. Turns out there are no x-intercepts because this guy doesn't actually cross the x-axis at any point. And if I think about that algebraically, I guess that kind of makes sense. The y-intercept should be easy to find if I just hit trace, and then it's actually already there. But if it wasn't there, you would just type a 0 and then enter. So the y-intercept is at 0, 3.46. And then there are 2 minimums. I already know this maximum, but there's 2 minimum points right here and here, and they happen to be symmetrical. So I'm just going to find one. I'm going to cheat big time here. And then I'm going to give the positive one once I find the negative one. And I'll have all my answers. So there's a minimum at negative 3.46, comma 0.003, which is close to 0, but not quite. And then I'm guessing the one that is over here is positive 3.46.003. So we already knew that this maximum was also the y-intercept, and it was 0, comma 3.46. And I think as long as you wrote those down, you have all the numbers you need. Alright, let's get the calculator out of here. I'm not even going to bother graphing that because my graphs on my tablet don't look so great. Now here, I'm going to give you a generic domain interval, and it says it's from -5 to 5. So let's go ahead and graph that. And there's something that happens at -2, and then also something that happens at +2. Now there's a bunch of answers that you could be giving me here. I need you to graph something that is increasing between -5 and 2, constant between -2 and 2, and then decreasing from 2 to 5. So it could be lines, curves, whatever you want. I'm pretty boring, so I kind of graph the same thing every time. There's an increasing interval, and then constant, and then decreasing. That works for me. This guy goes from -5 to 10, and there's some interruptions at -1 and +5. So it says that we are decreasing from -5 to 1, constant from 1 to 5, oops, it's supposed to be constant, and then decreasing again from -5 to 10. So again, doesn't have to look exactly like mine, but it should fit whatever criteria they ask. Okay, piecewise function from a long time ago. 0 is my boundary line, so I always have my kids kind of mark, okay, here's 0. Now on the first function, on the actual boundary line, which is where we always have to start, it's going to have a closed circle because it's got an equal to symbol. Let's go ahead and figure out what ordered pair we're going to start at. So if I plug in a 0 into the first function, I get the point 0, 1. So closed circle at the point 0, 1. Now I can only choose x's that are smaller than 0. So pick anything smaller than 0. I'm boring, so I'm going to pick -2. And if I plug a -2 in, -2 plus 1 is -1. So another ordered pair at -2, -1, and then I connect, oh geez, my 2 points, and I create an array, which is what you have when you take a line and stop from the boundary line. Now the bottom function is going to have an open circle on the boundary line, but even though it doesn't actually exist, I'm still going to find his starting point. So if I plug a 0 in, I get 0, 1, which happens to be the same starting point. So normally I put an open circle here, but it's already kind of filled in. And then I need to pick something bigger than 0, so I'm going to go with 2. 2 times -1, -2 plus 1 is -1. So 2, -1, and then we, oop, I kind of missed my point, but there you go. It's a filled in circle. It's only open circles on the boundary line. And it looks like an absolute value graph, and actually it is an absolute value graph. Now, when we're evaluating, if I'm using -2 for my x value, I have to decide if I'm supposed to use the top or the bottom function. And since -2 fits the less than 0 qualifier, I'm using the top function. So -2 plus 1 gives me a -1. -1 is also smaller than 0, so using the top function, I get a 0. +1 is bigger than 0, so I'm going to use the bottom function. 1 times -1 plus 1 is 0. And then 2 is going to be qualifying for the bottom function. -2 plus 1 is -1. These are also points that I could have got off of my graph, but my graph is not super accurate, so I went algebraic. Now this question is a little more exciting because, first of all, the boundary line is moved, so it's at -1. This is where my function is going to kind of split off. And the other exciting part is my functions are now going to be parabolas, or in our case, half parabolas. So on the boundary line, he's an open circle for the top function, but even though he doesn't exist, I'm still going to figure out my starting point. -1 squared is 1, 1 plus 1 is 2. So -1, 2 gives me an open circle. Now I need to pick another point that's smaller than -1, so I'm going to pick -2. -2 squared is 4, 4 plus 1 is 5. So -2 and then 5 would be up here. And then remember, whoop, kind of missed totally, but a parabola would look like that. Now for my bottom function, on the boundary line, again, it's an open circle. Be careful, because it's a negative times -1 squared, so that's end up being a -1 minus 2 is -2. Use your calculator if you're not too keen on doing that in your head. Make sure that you use parentheses. Now I got to pick something bigger than 1. I'm going to go ahead and choose 0. And if I plug in a 0, I get 0, -1. It's filled in circle now. And think about what this would look like. An upside down parabola shifted down 1. So your parabola is actually going to end up looking like this. Probably getting another point off to the right would have helped me a bit. For f of -3, that is smaller than -1, so I'm going to use the top function, and when I evaluate that into the top function, I get 9 plus 1, which is 10. And then 0, of course, is greater than 1. I think I actually already found this, but we're going to use the bottom function, and we're going to get a -1. Let's see. Okay, gotta get the old book out. Hopefully you have yours. Applications, page 79. Let's see, 79. This is a lazy teacher's way of not typing a bunch. Number 54. Oh, I don't think that's the right. That is not the right page, Abruzzo. What section is this? 1.3, huh? Alright, we need to fix that. 1.3 is actually page... That's funny. I can't read. It says page 54, number 79. Alright, it's time to go home. 79 says the revenue of sales of car seats for infants is given by this function. R of x equals 60x minus 0.035 x squared for x's in between 1700 and 0. And then it says, find the number of car seats that must be sold to maximize the revenue. Now, this is definitely a technology problem. So I'm going to go to my calculator, and I'm going to graph it. So go to y equals, which should already be programmed. Or you're going to program it, rather. 60x minus 0.035 x squared. Now they gave you a domain restriction, which is awesome. You're going to go to Window, and you're going to set up your x's to go from 0 to 1700. Now, I don't really know a lot about car seat sales when it comes to a big company. So instead of setting up the y's myself, because I don't know how much money they're going to make, I'm going to make the calculator do it. Since I set up the x's, I can choose what's called zoom fit. So press the zoom button, and then at the bottom, like a 10th choice, it says fit. So choose zoom fit, and it should adjust the y's to give you a pretty picture. Now, if it doesn't work, you might have to hand adjust it a little bit more. They wanted us to maximize the profit, so I think we need to find the maximum point. Well, let's do that. So maximum finder. Left bound, remember this goes from 0 to 1700, so I don't really know where my cursor is. I guess he's right there. 500 is surely to the left of it. And then 1200 is surely to the right of it. But again, you could scroll for the rest of your life if you wanted to. And then guess, there's only one max in this screen, so we can go ahead and choose it. And it gives you a maximum of 857 point whatever, and then 25,714.3. And the question is, what is the maximum profit? And find the number of car seats. So we got to figure out which one is which. Remember, X represents the number of car seats. So they should make 857 car seats, and their maximum profit is 25,714 roughly. It's an estimate, so we're going to estimate with our calculator. All right, and then same page, number 81. Oh, that's an exciting one. We've got a box. Let's see if I can draw this. Oh, goodness. But it's unfolded. Sorry, the pictures are hideous. And when you unfold a box, like an open top box, you kind of get these creases. And if it's done correctly, it'll be a uniform crease. So like they cut out the corners and fold them up, basically, is what's happening. So they tell us a few things. They say the box from here to here is 24 inches. And then they say the box from here to here is 18 inches, like when they started with the piece of cardboard. But then they're going to fold up the corners once they cut them out, and they don't tell you how big those corners are. So they're all X's because they're going to be the same size, otherwise your box wouldn't come to a even level. And the final question says, we want to maximize the volume of this box. So first thing we need to do is create an expression that represents the volume of the box. So remember, volume is length times width times height. Now we got to be careful here. The actual length of the box is no longer going to be 24 because we took off these two little x's. So the actual length of the box is going to be 24 minus 2x. And then the width of the box is no longer going to be 18. It's going to be 18 minus 2 x's. The height of the box is going to be how tall those cutouts were, which is x. So for our volume, it's going to be length, which is 24 minus 2x, times width, which is 18 minus 2x, times height, which is x. Now don't bother doing any more algebra because your calculator can totally handle this. Let's go to y equals, let's get it programmed in, and leave it exactly in the form it is given right now. 24 minus 2x, and then times 18 minus 2x. There was a day when we had to solve this by hand, and it was not a good day. But now we're going to use our technology, because that's the world we live in, and that's awesome. And I don't think they give us any sort of restrictions, but that's because there's natural restrictions in the problem. If your box is, like on its shortest side, only 18, you can't cut out like any size you want, because if you cut out too much, you'll have no more width of the box. So I think going from 0 to 5 would be plenty, because if you cut off 5 inches on each side of the box, you'd be cutting off 10 inches. Now, I might be way wrong, but we'll see. So I set up my X's, and now I'm going to do that zoom fit thing again, see if my calculator can get me a pretty picture of the maximum value, because remember, we're trying to maximize the volume. Okay, that's pretty good. So second trace, I want to maximize my volume, and my cursor's right over here, which is to the left. Enter. If I had my life to live over, I would have adjusted the window a little bit so my little stuff at the top wasn't in my way. Okay, I went to the right, I hit enter, and then I hit enter one more time, and it looks like to maximize our volume, we should cut out roughly 3.4 inches off of the corners, and it's going to maximize the volume to be 654.9, or we'd round that up to 655 cubic inches. Okay, excellent. And I think that is the end of our lesson, but let me check. Yeah. Good luck.